Oh boy.
You heard that too.
You're consenting to be recorded.
Uh,
I have to
that-
click continue. All right.
that's funny. Um, well, I guess Matt, have you watched what's been going on in develop, or can I
I
pretend you're my audience?
yeah, pretend I'm your audience. Yeah, I haven't seen too much. I've seen that you guys have like done some work to pull certain conceptual areas apart, but I haven't like gone away from the main thing and looked at like what does that look like. But I'm ready to hear
Yeah,
about it.
yeah. So, I don't have anything really prepared, but I just thought I'd talk about it. I'm going to share my screen here. Figure out how to do that. Share screen. Should ask me which one. That one. All right. So this is the cookbook app, and it's a like example. It's a good example of what's been going on because it kind of shows what's been happening. Like the cookbook app used to just have AudioKit and AudioKit UI as dependencies, but now you see it has a bunch of these audio kits. There's Done audio kit, Soundpipe audio kit, Sporth audio kit, SDK audio kit. And there are actually more audio kits in the world. So if we start from like I don't know, start from the top, like audio kit itself. Um, audio kit itself is it used to be AudioKit and C AudioKit. Now it's
Hmm.
actually three things. It's AudioKit, which is entirely Swift. So we should be able to import that into Playgrounds and have it be a very, very thin layer on top of AV Foundation for the people who only need that. And
Hmm.
then AudioKit EX are, is the Swift layer for things that are backed up by our own C code. And those are things like uh, sequencing, a couple of the nodes, callback instrument, and I could foresee there being a few more things that we include inside of here, but uh, it's kind of stuff that we're pretty like we know is fairly stable, like in a sense. It also includes the automation stuff that the parameter automation stuff that Taylor made. That's all in here, and it's kind of like the core code that we really can rely on and make be the stable base for AudioKit. And it's also
Hmm.
the code that like nodes and stuff that other audio kits can be built on. And that's what's kind of cool is that it used to be that people were wondering how they could uh, extend AudioKit, and there were problems like where they would create their own node, but something was public or was private that they needed, and so now we pretty much ensure that that's never the case because we have other audio kits that rely on AudioKit. So we take this Done AudioKit as an example. Done AudioKit is the sampler. There's a chorus and flanger and a few other things all written by Shane Dunn. And it's package.swift file. You can see it depends on AudioKit, and it also depends on this other uh, package that we created so that it could be included in a few different places from AudioKit. And so this is entirely like Shane's way of coding, his code. Um, it's C++. It has headers that are kind of interdependent, like both chorus and flanger depend on this modulated delay thing. And it's opinionated and good in its own way. Um, but it's kind of hard for us to. There's a couple reasons why it's great to move it out. Not everybody needs a sampler for their application, so why should they have it available to them? But also, like when something goes wrong in the in his code, like it falls upon us to like fix it. Whereas now, when it's
Hmm.
in Done Audio Kit, I feel like people who are experts at that particular realm, they don't have to muck around with the rest of AudioKit. They can keep their package, their sub AudioKit uh, working and just
Totally.
in order without having to dive in like worry about everything else.
That's cool.
Yeah, and there are other potential benefits like if there's a library that has if you have your own closed source library, for instance, that can be set up the same way, but then you have a private URL or a private repo that is set up as a sub audio kit. If there's a repo that has a different licensing system than we want in an audio kit, then that's fine. They can have a different license on that audio kit, and people who elect to use that sub audio kit can deal with obeying the rules of that particular license. Um, so audio kit operations got lumped into this thing called Sporth audio kit because it depends on um, the Sporth language, and so but Sporth depends on SoundPipe. So here's an example of a sub audio kit that not only depends on audio kit but another sub audio kit. So this package depends on SoundPipe audio kit. And I guess it only depends on SoundPipe AudioKit, and then SoundPipe AudioKit depends on AudioKit. So it kind of inherits the chain of package dependencies. And they're all kind of set up similarly in that if there's a external dependency like Sporth or SoundPipe, that's set up here as a target. The AudioKit wrappers is a target, and then the C layer or the DSP or whatever it is prefixed with the letter C and has the same name, C Sporth AudioKit. A lot of the tests that we had in AudioKit also got dispersed to the other AudioKits, so most of them have they all have continuous integration set up, and they should be as well tested as ever, except now that if you compile and you make a change to SoundPipe AudioKit, it doesn't run all the tests that you don't care about. So it's a little bit faster, I think, for developing on a specific thing. And there's a few other audio kits here. I'll pull up the GitHub here. GitHub.
Also, just to
Yeah, go ahead.
one thing that I thought was also cool about this is, and this is perhaps obvious, but I thought I'd say it anyway, which is that you get to pick and choose exactly what you need, so you don't need to wait around for other stuff to compile, which is really nice. People wanted that. If you have, if you have a slower machine, it might take really long, for your iteration, your work iteration. So I think this would be pretty cool.
And some of these things, even SoundPipe and SDK, they do have a lot of files, and you see them scrolling along, and you've got 14,000 different things that are compiling. You're like, what is all this stuff that I'm compiling? So yeah, that's cool. So the AudioKit GitHub page, we've been looking at Done AudioKit and AudioKit and the cookbook, but things like Soul AudioKit have gotten pulled out, and I'm hoping that it just has the one thing right now. So they all have, by the way, they all have documentation in the wiki. This one's kind of silly because it's only got the one thing, the diode clipper, but hopefully having Soul AudioKit separated might attract people to add to it, because it's really very simple when you see it here all alone. Actually, look at the CSOL. That's all that SoundPipe Soul DSP is. It's not really that much code. So you could learn this and then make an extension that does one of their examples, for instance. So I'm hoping this grows. AudioKit we have the dev tools for like building SoundPipe AudioKit wrappers and Swift files and stuff. I'm hoping to move those into these repos and make that be another way for people to extend these sub audio kits. Marcus Hobbs microtonal stuff, it's cool. I'm really glad that he's put a lot of effort into it, but everybody doesn't need it in their audio kit. So all of his tuning and table stuff is moved out, and fewer things to compile and fewer code completions to come up that you don't necessarily know what it's all about. Yeah, so the guitar processors removed, synthesis toolkit, AudioKit operations. A lot of the core effects have been moved to SoundPipe, so I guess a lot of people will be immediately using this as a dependency. But yeah, it's like, I'm writing up a new website for AudioKit, and instead of like just talking about AudioKit as uh, an audio framework, I'm talking about it as an ecosystem of products. Of there's different kinds of
Yeah.
people working on it. There's framework developers. There's audio engineers, graphic artists, a whole bunch of different kinds of people, and we're creating a lot of different things. I'm just really looking forward to seeing whether this change like kills AudioKit because it's like confusing or something, or whether it lets it flourish. And that's of course what we're hoping for. Um, so yeah, that's going to be a big change in 5.2, and frankly, it was my dream to have this as AudioKit 5. So this 5.2 is really what I wanted 5 to be. I actually thought this wasn't going to come until 6, but it's coming in 5.2. I think 6 might be like further extraction of like getting MIDI really right in AudioKit and extracting that out, that sort of thing. So there's still work to be done, but it's AudioKit itself is simpler, easier to use. I think more attractive to people who want to do uh, specific things for their own code that don't want to worry about all the other crap in AudioKit. They don't have to anymore. They just grab what they need. So yeah, that's been the focus of the last couple of weeks, and making a website that supports this is what I'm going to be doing for the next 10 days or so.
That's great. I think that the keeping the different like major sort of I don't know, they're not features, but they're like feature sets. I think that's awesome because then people see, when they come to the project, they say, oh, there's all these things right here, instead of being like, AudioKit does everything. It's the kitchen sink or something. It's like, oh, actually, here's all the things. You can just do whatever you like and extend it, or yeah, that's fantastic. Nice work.
Yeah, some
Great
people
training.
like the idea of everything being in one, and I'm expecting pushback from uh, the naysayers in the group. We know who they are, uh, but I'm not going to. I feel very strongly about this, and it's been backed up by most people's reaction to it who've seen it so far. So I'm pretty darn excited about this.
It seems like it would be pretty easy to provide like, the package, like a package file for the people who want everything at once or something like that. No, like,
Yeah, I was looking at this package collection thing that was announced in 5.5. I don't know if that's a way to do that, but certainly I'll just tell people look at how Cookbook does it, and
hmm,
you just go to the Cookbook and you look at the
seems trivial. Yeah.
Swift packages. Here they are. You just put
Right.
the URL in there and give it a. Oh,
Yeah.
I guess I should mention one other cool thing that's not yet developed because we haven't made the official releases. When we do make the release of Cookbook, or the main branch of Cookbook, this will no longer be developed. They will be fixed to a particular release of each one of these, and so that should allow it to be fairly stable for people who like say, I just want to keep 5.2 forever and wait like I just want to have a very
Mhm.
stable system. I don't necessarily want to upgrade, and be able to test out, develop, come back to it. All of the audio kits are going to start off at 5.2 versions, so that there's like a similarity between all of them. And a lot of them, they yanked out of audio kit, and I guess one of some of the downsides here would be that if there's a mistake or somebody changed something, uh, you're going to go to this repo, and it's not going to have a lot of history about the file because it used to live in a whole different repo. But I'm willing. I think that's a reasonable trade-off, because uh, the changes in AudioKit 5 were already so drastic that watching that progression. There wasn't a progression. There was like pre-Taylor and post-Taylor, and that's the end of it, right? There's not like this change. The changes all happened within a pretty narrow band. So um, I think it'll be
Yeah.
pretty clear. One of the other changes I've been thinking about making to AudioKit is uh, get your feedback on this, Matt. It'd be kind of funny. So if you go to AudioKit now and you go to, because you mentioned this the other day, like
Oh,
that I'm closing up all these issues. Like we have no issues and we have no pull requests. It's great, but I think I might I will at least change the description of the issue. So if you create a new issue, it's going to tell you to create a pull request with a breaking test if you want something changed, so that they have to at least go through the trouble of doing some code rather than just like describing it and stuff. I know that'll
yeah.
put off a lot of people or some people, but frankly, responding to the O1 gods of the world is not something I want to spend a lot of time doing. So
Yeah.
if and I actually got inspired by Sundell, Swift by Sundell. He has this publish framework. Um, what is it? I think publish. Let's see where it is. I can't type for shit. You know that. GitHub publish Sundell. Okay, John Sundell. But yeah, he has no issues. He just has pull requests there. It's like, and he has mentions at the bottom that if you wish to make a change, open a pull request, and like
Yeah.
it's pretty hardcore. I kind of like it. I don't know if I'll go that way all right away, but I think it's the kind of thing that will lead to like greater maintainability of AudioKit for me.
Are there any
So,
other features for like GitHub that are sort of more for non-coder community stuff? Because it's like really, if people aren't coders or they don't know enough about, the area that they have a problem with, it's like they could come and bring it up in chat, and most likely they're going to have that,
yeah, so
someone's going to be like, oh, I'll make an issue or whatever and figure it out. But
they created this discussions thing, which I haven't
yeah,
tested out yet, which I think is kind of for that. So I could turn that on, but I don't know.
you don't know what you'll be.
Yeah, exactly. It could just be. I kind of like telling people to go to Stack Overflow. Part of Stack Overflow is trying to put some legitimacy to AudioKit, that if you do search on a Stack Overflow, you should see people talking about it. I would like to have that rather than it spread out between Slack and discussions and issues, projects. I closed that down recently.
Yeah.
So yeah, we'll see how this turns out. But like I said, pretty excited.
That's awesome. Yeah, it looks, I'm psyched about it. It sounds great. When you told me about it, I was like, oh yeah, of course. That makes a lot of sense.
Yeah.
Yeah. Awesome.
Yeah. Anything you wanted to add that I missed, Taylor?
Nope.
Cool. So let's switch over to your stuff then.
Yeah, let's see. Can I share my screen? Does it start share? Is that what
It does. We can, or we can do this.
Start. Let's do host disabled participant screen share.
Okay, let's see if I can fix that. Home. Okay, so I'm going to stop my share, and then I'm going to participants, security, allow participants to share their screen. Okay, should be able to do it now.
Share. Oh boy, desktop one, Keynote. There we go. Hopefully this works when I go full screen with it. Can you guys see that?
Yeah, I think it's fine even if it doesn't go full screen, but it's perfect.
Is it full screen now?
Yep.
And you can see it?
Yeah, that works.
Okay, so, well, I guess, so what kind of motivated this was that we pulled apart all this code and moved the C++ stuff out so that you really had this, Swift only part of AudioKit, which is just the AudioKit target. And it was just kind of bumming me out that I'm not supposed to write DSP code in Swift. So Apple says that they don't recommend it. If you create like a new audio unit plugin from the template, it's in Objective-C and, well, really mostly C++, because Objective-C, doing Objective-C stuff is, you know, not real-time safe either.
Right.
So, of course, in Objective-C, it's like it's easy to know what the subset of it that is real-time safe, which is just C. So it's easy to constrain yourself. Maybe I was thinking maybe you could constrain yourself in Swift. But anyway, yeah, I was sad about that. So I was thinking like, what might a, you know, some DSP code look like? So here's a really simple bit of DSP code that does a biquad filter, and of course I've omitted all the code that sets up the coefficients, blah blah blah. It doesn't really matter. So I'm not actually gonna run this. I'm just gonna just generate the LLVM IR. It's the intermediate representation, which is generated by the Swift compiler, and then LLVM converts it to machine code. And when this is the tick function, I can see in there just as, can you see the pointer? You guys can see the pointer, right? Okay, good.
Yeah.
These are mangled names, but I can see tick in there, so I know it's the tick function that I declared right here. So anyway, I just scanned down this, and there are these LLVM intrinsics, which look fine. Pretty much everything looks pretty good. Get element pointers, how LLVM does the pointer arithmetic. I wrote like a compiler for kind of a toy language that I came up with last year. So I'm kind of somewhat familiar with LLVM from using its C++ API. So that's come in handy in this little exploration. But yeah, so I'm just looking through this. There's no Swift API calls. It's just a bunch of loading of values and multiplying floats and adding them, this fmol and, you know, all this stuff. And I didn't even put the entire function here, but it's just more of the same. So then I was wondering, okay, let's try actually writing a stupid little audio unit with that. And you know, where exactly does this break? When does it start doing stuff that's not real-time safe? Because this last bit, this was fine. This is real-time safe. And so I'm gonna make an unsafe mutable pointer to the biquad filter. I'm not gonna even bother allocating anything because it's, again, I just want to look at the IR that's generated for this block. That's all I care about, because that's what I care about, is that real-time safe. Okay. Well, and I created some function called set sample so that I could set the sample in the you know, the buffer or whatever. So then I look at that, and that looks pretty good too. You can see here that the actual call to tick is happening here. That looks fine. That's just calling the function directly. And it's doing this, this I think is to check to make sure that something is not null. It's gonna break, if it's gonna compare something with 0, so that's null. And then it'll break to label 16 if that's true. And then that's gonna, you know, trap out, so it's gonna abort. But then it's all well, then it gets over here and it stores the float. So it looks like it inlined. I ran it with the optimizer on. And I did do a no inline attribute for the tick so I could see where that's being called. Because that would easily tell me where to look. But not for this other function. So it looks like it inlined there, and you know, it's simple stuff. It's kind of close to what you would expect if you just, you know, wrote the equivalent thing in C and generated the LLVM. Okay, so that's fine. No, when does it break? Let's get rid of that pointer. Remember, this one had this unsafe mutable pointer here. Let's just put the biquad right in the audio unit, and then we will use self. Okay. That gets longer. And it does some stuff that I'm not exactly sure about. It is calling tick again here, simply. But you do have these other functions, these other calls I'm not sure about. And then I think it's doing some indirect calls. So like here's this 25, which is a pointer which is generated here. So it's cast to a function pointer. Something is cast to a function pointer and then called. So that might be sketchy. I'm not sure, but
That's probably the. I don't mean to interrupt you.
Go ahead.
I can wait. I can wait. Sorry.
No, go ahead.
Oh, it's I've been looking into a lot of like capture and like closures stuff, and maybe that's partial. Maybe that's like the closure itself, because like, what is it? Closures or methods or functions, however they want to call them, are like reference types, and yeah, I don't know. I've been looking into that, so maybe that's part of that. I was wondering this.
It could be, except that
where does that get set
the
up?
tick has already been called.
Yeah.
So I'm not quite sure what it's about. Probably some Swift expert can tell me.
Yeah, right.
And but anyway, so I'm kind of like, okay, maybe this is okay, maybe it's not. But when does it become like obvious that it's
yeah,
that it's bad? Let's do something that you shouldn't do anyway, which is to create like an array of samples right in here, and then I do something that makes no sense, of course, but for the purpose of this example. And then I've omitted most of it because it's already doing bad stuff. Bridge, object release. There's a couple other calls in there that aren't any good. So we definitely can't use Swift arrays. It might be smart enough to know if you have like an array that's constant size. This, of course, is dynamic frame count. If it was constant size, maybe it's smart enough to optimize that into a stack array. I wouldn't chance it.
Right.
So
Interesting.
yeah. So I was thinking of having something that actually just looks at that IR for you and validates the function. And that I was thinking of having a little attribute called real time. And I started working on this, which has gotten further than I expected, actually. So here's like a little, predicate for looking at the LLVM function using their API and determining, according to some simple rules, whether it might be real-time safe. We're just going to iterate over all the blocks in the function, iterate over the instructions in the blocks. If they are call instructions, then we go and grab the called function. And then if it begins with Swift or underscore Swift, we know that's a Swift API call, and then we return false. Also, you could detect indirect functions here, because if get called function returns null, then that's an indirect function call. So like calling through a function pointer or something. And that might also be bad. So anyway, so that was cool. And then it turned out, and Ari and I worked on this together, actually. It turned out writing the LLVM pass, which is like a little object that gets called on every function in this case, was pretty easy. And the main thing that you had to write was this function. So we created this little Swift real-time verifier and stuck it in the Swift code base. And it run on function, and then there was a little plumbing that I had to do to get this metadata stuff to show up, but there's some metadata that I generate in the earlier stages of the compiler just to say that this function needs to be looked at to be, is it real time? And then it's just calling it's real time safe. So if it's not real time safe, then it's gonna print out something. So that's cool. And it's going to be interesting to see how far we get with this. It's kind of early days. There's there might be something that that I don't know about that's gonna doom it. Um, but I don't know. There was some pretty knowledgeable people on the Swift forum that didn't seem to think it was impossible. So I guess I'll keep going with it. It just seems like something that I don't know, you would want, that like Apple would want themselves and the audio team would want,
Mhm.
So I kind of wonder why it doesn't already exist, and maybe I'll find out the hard way, but at least
Yeah.
I'm, learning stuff about how the Swift compiler works and um, you know, so
Yeah, so as it stands now, as I understand it, the we could write, or somebody could write some DSP code, and we could check it by putting at real time in front of it and make sure that it's okay and allow it to go into AudioKit or whatever.
right.
Um, but we don't have the ability for other people to test that unless they go through the trouble of making these customizations to their Swift tool chain as well.
Yeah, yeah, yeah. So they'd have to like download my fork. I mean,